Hello, everybody, and welcome to GED Science. It's been over a year since I made the first. Let's see, that's still, yeah. I made a GED video about so, and it's cool because YouTube actually split this up into sections with their AI algorithms or whatnot. And so at about 5 minutes, then I go into like a code pen. Yeah, there's me, younger me. But actually, this was how long ago? No thanks. This was 1 year ago. Open source computer science. So I've talked about that before. A lot of the stuff that I do was like incorporate, or I did was incorporating HTML, CSS, and sometimes JavaScript. And then this is when I was streaming and all that. So it's kind of cringy. I don't know. I didn't like it. I do want to go back and redo all of. I want to redo the math, but let's first go to science, and also talk about how you get here. So first you go to GED.com, and so as I understand it, it's just a national company that administers the tests. Here's like some statistics to sell it, and and you do need your GED or your high school diploma for pretty much anything anymore. And and you shouldn't even be stopping there. You should be doing community college and all this just randomly too. Like no matter what you're doing, what's your profession, it's always a good idea. So to do that, you need to do your GED. And kudos to you for coming and trying to find these types of videos too, because it takes a bit of effort to like get there, and then it takes a lot more effort to just maintain that. Like that's why we'll be trying to do these in like little 30-minute videos each one. So anyways, let's get started with the test. Oh wait, so first to get here, GED.com, and then you go to study, and down to test previews, and then it'll actually change to study free online GED tests. So these are the free sample tests, and then you have to sign a user agreement. And I was reading through it. It doesn't. I mean, if they want me to, I'll take the videos down. But as far as I know, like this is kind of fair game. It's like to test out the software. Kind of this is like a how-to kind of, but also studying for your GED. So, anyways, and these are very good hints. Don't spend too much time on a question. Monitor your time, like however much time they give you when you actually go and take this test at an actual proctored location. See, that's where the actual cost is. So like this stuff is free. Anybody can get this link. And that was also the other thing about the agreement is it kept talking about a CD, which we haven't used CDs for probably over a decade now. And like I don't know, at least for stuff like this, you have the URL. You can get to this practice test. This is the quote unquote software. So, anyways, just be aware of that. Like, don't be trying to like make your own. I don't know. Anyways, especially to profit off of. That's where they get you. I don't think they really care so much if you're just doing it for educational purposes. I hope not, 'cause that'd be pretty sad. But, anyways, enough of my soapbox. So, hope you've been reading here a bit. Like, I'll pause the video now and read it all the way through. But I mean, it basically is saying like, don't waste all your time on one question. Try to get as many done possible. Like, scatter, answer as many possible as you can. Yeah. So next. All right. Okay, so here it's talking about plate tectonics. And if you haven't heard about plate tectonics, that's where the Earth is actually comprised of plates that move around. But if you didn't know that, I mean, I learned that from a geology class in community college again. So like easily, we should make this accessible for everyone. But anyways, it's asking what which conclusion can be reached from the information on the map. So right away you're looking at it, and it's like what makes the most sense? Well, oh, there's a lot of active volcanoes on the coast of these countries. So already there's a question that's close to right, like, so it's not scattered randomly across the earth because there's definitely lines. Like if it was random, it would be like a scatter plot, like a shotgun blast or something. But anyway, so volcanoes are only located along edges of continents. Well, you would think so from this, maybe some of that, like the illusion or whatever that is, and then this. However, you see all of this, and then in the middle of the ocean, and then more so along these lines. Like look at all these outliers. So I mean, this is an okay answer. It's better than scattered randomly. So that's more right. Then volcanoes are mostly located along boundaries between plates. Yes. So and then you have plate boundary line, and so plate tectonics is where since these are plates moving, they're allowing for volcanoes to form, and that's the backstory to plate tectonics in a nutshell. Let's see, volcanoes are distributed equally in the northern and southern hemispheres. This one, because you still want to look at every answer, there could be a more right answer, especially when you get into like certifications and stuff for tech jobs and tech things. But anyways, which you need your GED to do. So actually, no, you don't. But anyways, volcanoes, they're not distributed equally amongst northern, southern, or eastern, western, because if you were to count all of them up, actually there's a lot there, so it could be close. Even if you actually counted all of them out, northern definitely more, because even like this little part, okay, so that takes care of that, and even that, and then if you took like this for this and this for this, you would still have all of this for this and this. So yeah, and then even east and west, like if you drew a line anywhere, it's not really, I don't know. That's less correct than along plate boundaries. So, and then they have the equator just for like kind of like north, south, east, west. Anyways, I think you can check. Let's see. Well, let's see. I think we'll just go through what we're doing on like 5 minutes in. All right. So let's see. The diagram below shows a typical energy pyramid. So, and this kind of did confuse me a little bit. Tertiary, secondary, and primary are first, second, and third. Like, and then producers. So these are the ones that are making the energy. These are the primary consumers. So they consume it first. They're the closest adjacent. Then secondary, they consume it second. Tertiary, third. So as the energy is produced, so let's see, which statement correctly describes the flow of energy through this pyramid? All of the energy from the lower levels is available at the top level. No, because even this, like, they produce a lot of energy here, and then it gets smaller and smaller and smaller. So let's see, the producer level directly provides energy for all of the other levels. Well, that's not true either, because this one doesn't share a boundary with the producers. Well, actually, wait, the producer level only directly provides energy to the primary consumers. Sorry, so that's even, that's wrong. The highest amount of energy is transferred between levels that contain consumers. That's not correct, because producers have the highest amount of energy, so it's not that one. Then energy is directly transferred from the primary consumers to the secondary consumers. Yep, it is directly there, so I would say D. And just again, to just double check, because like even then, like all of the energy from the lower levels available at the top, no. Producer level directly, no. Okay, just to make absolutely sure, because that took what, like 10 seconds just to reread them real quick, make sure it makes sense. And that's the other thing, is like really look at the pictures. Like what? Okay, so if we're talking about energy, and we're talking about, let's see, the highest amount. So once you're seeing stuff like that, that means, although it's not like lower levels could be confusing as that, but the highest amount means that you're comparing something. Now, as far as this, lower levels, you're still comparing something. You're comparing whether it's a lower level or a higher level. For this one, you're saying the highest amount of energy, and this is an energy pyramid, so I'm going to guess that, I can't like just highlight the bottom part, but that bottom part looks the biggest. So if we're talking food pyramid, the bottom part, the grains and everything, that's always the biggest amount, so it makes sense you could relate that to a pyramid. Energy is directly transferred from primary to secondary, so yes. That's the flow of it. So, and actually, you could think of this as like a food chain, like the energy from grass to cows, or sorry, I mean, grass to people if you're vegetarian. But anyways, and then the sun to the grass to the people to the, and then it kind of gets stuck. Anyways, cycle of life. Wait, did we just skip? No. Okay. The scientist collects data on the solubility of different salts at different temperatures. The results are shown in the graph. So solubility is like how much they dissolve or melt. So I believe, at least in this point, at different temperatures. So that's like, I want to say like, yeah, turning to a liquid or melting. Let's see which conclusion is supported by the data in the graph. So as the temperature increases, never mind it's in Celsius and we're used to Fahrenheit here in America, but it's increasing. So it's 0 to 100, and then here, the solubility. So even if we don't even know what that is, it's increasing as temperatures increase. Here, like, it actually decreases? I don't know. And whatever that salt is, I think is a negative effect. Whereas this one is like the highest, and then the most direct of a line, even like the steepest slope is how you know you have the most change between 2 points. So, and this is like an exponential curve, and then it's like flat lines and almost never touches the value. It almost looks like, anyways. So solubility always increases as temperature increases. Well, that we just proved is not the case with this purple outlier. So then, and also make sure you like, mark it with these because even if you forget to answer, you have a 1 in 4 chance to get it. I mean, that's not like a good thing to depend on, but it is just something to know with standardized tests. So, or any kind of, ACTs, SATs, GEDs, all the tests you need to get into college, then every test you take in college. So, anyways, at 40 degrees Celsius, KCI has the highest solubility of all the salts of the table. So now I have to find KCI, so it's the green one, and then at 40 degrees. So no, that's incorrect. Blue and red are easily higher, so that's not correct. So the rate of change in the solubility of Kino 3, Kino Reeves, changes as temperature increases. So yeah, as temperature increases, it changes. So and it definitely. Oh wait, the rate of change. Sorry, the rate is how. So that's like the curve. So this one, it's like the rate of change stays the same because it's a straight line. Both the purple and the blue have curved lines. If you look really closely right here, and then it continues up like a parabola or just some kind of curved line. So yes, that is correct. But let's double check this one to make sure if this isn't more correct. The solubility of NaCl, which I believe is salt, sodium chloride, does not increase, or just basic table salt, isn't it? See, they said these are different salts. Anyways, so yeah, this is salt, that's salt, that's salt. Sorry. Does not increase with increasing temperatures above 80 degrees. So we look at NaCl 80. So it does increase barely, but it does. So as the temperatures get higher, there is still some yield. So we confirm that it's C, at least going through that. And then here, it's a lot to read. Let's see. Actually, let's skim it. Tropical rainforest. Or, no, let's read it. Okay. Tropical rainforests contain diverse communities of organisms with many interesting relationships. One such relationship connects parasitic fungi and their insect hosts. A type of parasitic fungus called Ophiocordyceps unilateralis or something disperses spores onto the forest floor, but cannot successfully grow on the ground. The fungus requires specific conditions and must grow inside of a specific ant species called the host to reproduce. The ants' various species of carpenter ant make nests in the trees. So then O. unilateralis feeds on and grows inside the insect host, and within a few days the fungus attacks the insect's brain. The insect exhibits unusual behaviors, such as wandering away from the colony to where light and humidity favor fungal growth. Just before dying, the insect bites into and firmly attaches itself to a plant. Then the fungus slowly grows outward from the dead insect's head, producing a pod of spores that eventually bursts open. The spores fall to the ground, restarting the life cycle of the fungus. Deforestation or clearing away trees is occurring in tropical rainforests. Explain how deforestation could disrupt the life cycle of Ophiocordyceps unilateralis in tropical rainforests. Include multiple pieces of evidence from the text to support your answer. Type your answer in the box. May require approximately 10 minutes to complete. We're going on 13 minutes for, 4 out of 10 questions. We don't have that time, but they give you 10 minutes. So let's talk about, all right, so deforestation, less trees. I'm just writing in, like, you should write complete sentences, but I think, yeah, right. Less trees, or no, so with less trees, there are less, let's see, hold on. So deforestation disrupt the life cycle of the. So you got to think about what's really going on here, because so the fungus infects the ants. The ants have to carry it to where it's sunny, be attached to a plant. So with less trees, there are less plants. Less plants means less places for the fungi to grow. However, I mean, depending on if the plants can still survive without the trees, so it depends on the whole deforestation. It's clearing away the trees is occurring in the. Because here, oh no, it does say they need to make nests in the trees. So right there, the ants. No, sorry, with less trees, the ants. Sorry, right there. The ants make nests in the trees. So with less trees, the ants wouldn't have homes. And then, so we don't even need to have that. So right there, that's one thing. Just boom. And then, let's see, what else in there? Grows on the insect, goes to where light and humidity favor fungal growth. So that could actually mean a few things. Like it could be darkness or light. Like, so that could be another thing. Fungal growth, I feel like usually, wait, let's see. Does it say somewhere in here? Like, but cannot successfully grow on the ground. So inside of an ant species called the host to reproduce. So it does have to be kind of close to trees, which you imagine would have leaves and foliage, and so blocking the sun. That's why I'm just seeing, like, I don't really see a lot for mentioning of sunlight, just that for fungal growth. So where light and humidity favor fungal growth, which usually is dark and damp, but not always. I feel like it can grow in like damp and sunny. But I know from a fact that with less trees, the ants wouldn't have homes, and they need the home. So and then you should like follow up, like the OC or the OU needs ant hosts for the early stages of its life. So right there, as it's like growing, until it can infect the insect's brain, and then so let's see, feeds and grows inside the insect host, and then within a few days, so it needs that period of a few days growing inside the host. So I know this is really like beating it to death, but 10 minutes we did what, like a couple minutes. It's really you should even go even more if you can think so. Like let's see, just before dying, let's see, then the fungus slowly grows outward from the dead insect's head, producing a pod of spores that eventually burst open. The spores fall to the ground. Oh, so wait a minute. Restarting the life cycle of the fungus. See, so I still don't even know about the light level, because it grows outward from the dead insect's head, producing a pod of spores that eventually bursts open. So we're talking about it attaches itself to a plant. See, I thought that was like, so it's good for fungal growth, but yet you're bite into and firmly attached to a plant. It doesn't even say like leaf, stem, just a plant. And then fungus slowly grows outward from the dead insect's head, producing a pod of spores. So it doesn't even really feed on the plant. It's just, yeah. It just needs to be a stable place for a pod to be there that eventually bursts open. So that might be the case. Like it needs to steady itself on a plant, and then the spores fall to the ground, restarting the life. So yeah, there's nowhere where it feeds on the plant itself, just the ants. So yeah. OU only seems to feed on the ant, only using the plant for secure, for stable positioning for the pod. Or something like that. You can say whatever you want, like as long as it like addresses these points. So you're like going back, inspecting pieces of it, and still, even that, like I had time to read it. And that's why also reading is so important too. So yeah, like anyways. We'll go there. We'll call that good for now. And they can't really grade it. So then, all right. So 5 out of 10. Is this the same thing? Yes, I believe it's so. Oh wait. Which fact from the passage supports the argument that parasitic fungi offer at best severely limited potential as insecticides that target many kinds of insects? Let's see. So I just like to read the question before I go looking for it, so I know what I'm looking for. Um, so which part of this says that the parasitic fungi thing, the O. unilateralis that kills the ants, at best severely limited potential as insecticides? Well, well, I can tell you right now, it relies on an ant host. Some of the fungi may be host-specific parasites. Some of the fungi produce pods that grow from an insect's head. The fungi entirely control the insect's behavior. The fungi reproduce inside an insect's body. So both A and C are relevant, but also, I mean, this isn't like, that's not why it would be a limited potential. So it wouldn't be good as an insecticide. Well, first off, it doesn't target any other kind of insect except for an ant. So like host-specific parasites, some of the fungi produce pods that grow from an insect's head. Well, so I don't know. I don't think it. Let's see. Tropical rainforest grow inside a specific ant species. So right there, just to double check. So this is still the same. This page. This is not the same. So some researchers are studying to see if it's good for insecticide. Others argue that. So that's just setting you up for like what the question is. So anyway, so now you know where to focus. You can keep looking back here and just make sure. I'm going to say this isn't relevant. The fungi reproduce inside an insect's body. This isn't relevant. But I mean, it is like, because if the insect, that's actually a good thing for an insecticide. If it only survives in the insects, once the insect dies, it dies. Like, that would be good, but it doesn't, and that's not the behavior of it. It doesn't spread quickly like that. It just takes a few days inside an infected ant. The ant slowly dies, and although I wonder how many ants at a time. Anyways, that's not what we're being asked. So some of the, yeah, so that's host-specific parasites. Some of the fungi produce pods, so that doesn't matter. Um, that doesn't matter. I mean, that's just a part of it. So, anyways, so it's not. Wait, sorry. So to answer it, limited potential as an insecticide that targets many kinds of insects because it has to be the ant. Sorry, that's just to really drive that home. What they were asking, what the answer is there. So hopefully that's good. All right. So Newton's second law of motion states that the acceleration of an object is dependent on the object's mass and the amount of force applied to the object. The table shows data from an investigation of Newton's second law. So which statement describes the pattern established in the data included in the chart? So even just looking at it, as force goes up, mass and acceleration. Oh, wait. So more mass, less acceleration. More mass, less acceleration. That makes sense. So like a slower, like a drag. Let's see. But a doubling of the mass. Oh, here we go. So now we're talking in relation. So now that's just like a general overview of what's going on. So with a force of 8, so I think it's like 8 joules or just like 8, I don't know, like pounds of force or whatever. I think it doesn't even say. Acceleration of its been object mass. The force applied to it. So the force could be measured in newtons, I think, or N. I don't know. That's a whole different thing, actually, now that I think about it. That's like joules for. Anyways, this. So as this increases, as this doubles, a doubling of the force. Oh, wait. A doubling of the net force increases acceleration 4 times when the object's mass is constant. So when the mass is constant, that'd be 2 and 2. So 4 and 8, that is a doubling. So a doubling of the net force increases acceleration 4 times when the object's mass is constant. But wait, that's only for doubling of the, so if we do 4 and 4, so if the mass stays the same, 4 and 4, and doubling the force, that doesn't work. Because it's not 4 times, it's 2 and 4. Wait, no, sorry. Wait a minute. See, this is why it's tricky. So we're keeping the mass the same. So 2 and 2, 4 and 8, and we're keeping it the same with 4 and 4, 2 and 4. So it's not 4 times, it is doubling. So a doubling of the net force decreases acceleration. Well, that's not true when the mass is constant, because 2 and 2 is an increase. And the doubling of the net force. So moving from here to here. So you're moving from 8 to 16 for the left part of this sentence. And then here, saying, oh, well, and then constant, so then you're going back to this middle part. This one has to be equal to this one, so it's staying the same, or constant, or it's constantly being 2, or constantly being 4. Anyways, let's look at the other one, because it's not decreases acceleration. So acceleration, this is that number, so it goes up. Both of them go up, so 2 goes up to that. And it's all constant, actually, now that I look at it. So let's look at this. So doubling of the mass decreases the acceleration of the object by half when the net force is constant. So we're still doubling the mass. Oh, wait. So 2 to 4 decreases. Yep, and then 2 to 4 decreases. So I could see this being it. A doubling of the mass decreases the acceleration, so smaller number here, of the object by half when the net force is constant. Okay, so now we're dealing with 8, 8, and 16, 16. So 8, 8, 4, and 2 as mass increases. And 16, 16, 8, 4 as mass increases. So yeah, it's going down, and that is acceleration. So as friction's applied, which was more mass, so a doubling of the mass decreases acceleration, slows it down by half. Oof. Now let's see, if we want to get specific. So already, let's see, a doubling of the mass increases the acceleration. So we know that's not true. And this one, we know that A and B aren't true, so yeah, C. Alright. And then, because we're just at, this might go a little past 30 minutes. I'm looking at it now. We've still got 7. And we might want to go back. Or if it's wrong, we'll go back and see why it's wrong. Because there could still be a one wrong. I'm not 100% on this. I'm just saying, like, for time, if I only had 5 minutes left, okay, yeah, let's pretend like I did. So, boom. See, like, okay. So that's a lot of reading, that and that. So this will go past, but hopefully they give you enough time to read these. Plus, I've been yammering. Anyways, the diagram shows an event that occurs during meiosis. So paternal, maternal, and then they do crossing over, and then they separate with crossed genes, or cross that. What is the result of this event? Well, the paternal has some of the maternal, and the maternal has some of the paternal. So chromosomes that are genetically identical to the paternal chromosomes? No. That's talking about phase 1, phase 2, phase 3. That's not the same. So chromosomes that are genetically identical to the maternal chromosome? No. Chromosomes that are a genetic combination of the parent chromosomes? Yeah, I can see C. Chromosomes that contain a different amount of genetic information than the parents? No, because none of the genetic information is lost or gained through this. It's like a complete swap, just crossing over, and then boom, because they're still the same size. So yeah, so C. And then this one, dissolved carbon dioxide gas, CO2, creates carbonic acid in ocean water. Rising ocean acidity levels may harm marine life. For example, high acid levels may cause hearing loss. Scientists conducted an investigation to study the effect of increased acidity on fish hearing. A group of fertilized fish eggs from the same parents were divided into 4 different aquariums, each with a different pressure of CO2. One tank contained the normal atmospheric conditions of 390 microatmospheres of CO2. The other tanks contained 600, 700, and 900 microatmospheres of CO2 respectively. The same number of eggs were placed into each aquarium, or was placed into each aquarium, I guess. Anyways, the eggs hatched and the fish lived in these aquariums until testing. So different pressures, very little pressure here, double almost, and then actually double, and then, even more so. So, wait, yeah, that's the normal condition, so increased, there you go. So to prepare for the experiment, one fish was placed into an aquarium containing the same CO2 pressure in which it was raised. The fish's position was recorded every 5 seconds for 2 minutes. Then sounds from a predatory fish were played from an underwater speaker at one end of the aquarium at a volume that was only audible to the fish when swimming near the speaker. The fish's position was again recorded every 5 seconds for 2 minutes. Trials were repeated with fish from every tank. So they're going to see how long it takes for the fish to notice the sound and where they move. So scientists infer from the investigation that fish raised in water with higher levels of acidity have difficulty hearing predatory sounds. Which excerpt from the text supports this inference? Rising ocean acidity levels may harm marine life. For example, high acidic acid levels may cause hearing loss. Okay, alright, let's see. The study showed that fish raised in elevated CO2 levels did not avoid the sounds of the predator fish. Now I kind of want to see if that, I don't know if that's in there. This says how it's setting it up. This talks about the actual results. So we're saying which excerpt or which part of the text from the text supports the inference. So I don't know. Wait. We just talked about how it was going to do it. Here, we'll do this. Control find. The study showed. See, it's not in there. Even showed is only there. So, oh wait, page 2. Oh my gosh. We didn't even read. The study showed that the fish raised in elevated CO2 levels did not avoid the sounds of the predator fish. All right, never mind. But that is the answer. So, it concluded that it did. They spent approximately the same proportion of time at the speaker end of the aquarium before and after the sounds of the predator fish were played. However, the fish from the aquarium with the normal atmospheric CO2 pressure avoided the speaker end of the aquarium after the predator sounds were played. So right there's visible, observable evidence that they heard the sound. So, because they're predatory fish, they don't want none of that. So, yeah. Next. Anyways, so I didn't even know. We could have even we might have to go back and read that. So, anyways, dissolved carbon dioxide gas, CO2, creates carbonic acid in ocean water. Rising ocean acidity. Wait, is this the same exact thing? Again. Then page 2. Right, so identify the independent and dependent variable in the investigation. So independent, um, no, we had number of eggs in that. Let's see. CO2 pressure was the dependent. Wait. Sorry, hold on. Now we gotta think about this. So the independent and dependent variable in the investigation. So the eggs remained the same. Didn't matter. The CO2 pressure was dependent on which tank. Position of fish. Wait, what? Wait, what? Hold on. Identify the independent. Oh, so it's only two of these. So let's think about that. So the dependent variable, position of fish, and the independent variable was the CO2 pressure. So yeah, the number of eggs did not vary, and the same with the temperature of water. Sorry, wow. I thought for some reason we would have to sort all of those. So, anyways, correct variable into each box. There's only two boxes, four variables. There you go. But yeah, just to explain that a little bit, so the position of the fish is going to change, and they proved that the fish from tank A or whatever had different behavior. They swam away from the speaker, whereas fish from or tanks B, C, and D, the 6, 7, and 900, they did not. I think is what they said. The only wait, right now here the conclusion. They did not avoid the sound. See, even there, you can just double check just to be sure. Levels did not avoid the sound of the predator fish. So this means any of the raised CO2 levels. So even there, we can highlight that and be like, okay, there, and then read that. So the levels did not avoid sound. So yeah, so right there, the position of the fish was determined by or depended on what we did to the fish. Now, the independent was the CO2 pressure, because that's what we were changing. The elevated CO2 levels is what we were still changing, a variable. So these are the two variables, and these are the two constants. So remember a little while ago we talked about the constant, or if the force was constant or mass or whatever it was, that doesn't matter. It was what didn't change. So the number of eggs was the same, temperature of water was the same. We weren't trying to kill the fish. We were just trying to make it deaf from higher CO2 levels. So right there, there's your climate change stuff. But anyways, so 10 out of 10, this is question 10. Researchers collected data to determine volumetric bone density for 4 samples. The data are recorded in the table below. Let's see, so samples 1 through 4. The mass is different, doesn't look like any relation there. And then the volume of the sample. All right, so mass, that's pretty high, that's pretty low. Those two are kind of similar, so there almost seems like, oh wait, never mind. And then they give you a formula right here. So what is the average bone density for the data samples provided? All right, so we've got 4 samples, and we got to have the bone density. So the density is calculated by the mass divided by the volume. So we got to do this divided by that divided by that, that divided by that divided by that. All of that summed up, I want to say, and then divided by 4. Let's see, can we do a calculator reference? Oh my gosh. Calculator. So 6.8 divided by 22.6, because that's the density. We could just look at the density of sample 1. So 6.8 divided by 22. Oh, jeez. Okay. You can't really. Oh, that's ghetto. All right. So 6.8. Sorry. It's not. Oh no, this calculator is not operational and is include only. Are you kidding me? I gotta do this with my own. All right, so whatever. That's 7 divided by almost 21. That's like 1/3. So already we know it's at like 0.31 or 0.36. So to get it precise, yeah, let me pull out a calculator. I think you're allowed to have your own physical calculator, but you got it on your phone. All right, sorry, my phone is just really slow because I got all this stuff going on. All right, just kidding. 6.8 divided by 22.6. That's 0.300. So 0.3008. That's okay. So that's closer to this than 3.6. So let's do another one. 3.6 mafia. Anyways, 1.7 divided by 5.4. Okay, that's 0.314. So still hovering around 3.1. Now let's do 3.6 divided by 11.3, 0.318. So again there. And just to finish it out, 5.2, 17.4. Oh, and actually 5.2 divided by 17.4. So that is why you do want to. Oh, geez, and now do I got to write this? Like, hold on. I got a pen and paper. So, 0.298. And what were the other ones? 1.7 divided by 5.4. That's just the first one I saw. So we got a 318. Sorry, a 314. No, 315. Let's just round it to 3 decimals. So 315, 298, and then the third one is 36 divided by 11.3. So that's 319. And then first one is 6.8 divided by 22.6. So I did those kind of a little wonky, but it's okay. The order doesn't matter as long as you have the four values. So you got 301 because it's 30088. So we got 301, 315, 319, and 298. So now I'm going to clear that out and add those together. So dot 301 plus dot 315 plus dot 319 plus dot 298 divided by 4. Wait, that doesn't. How did that not? Wait. Do backspace. So that's 1.233. 1.233. Yeah, okay. So I just had to write on the next one because parentheses matter. All right, so once you get your total, so 1.233, then you divide that by 4, you get dot 30825, which is rounded to dot 308, which rounded to 2 decimal places is dot 31. So we know it's that one. All right, so let's actually just go for it. Let's submit, and then you'll now have an opportunity to review the questions and your answers. Okay. So answered all of them. Yep. Oh, wait. Do we have to mark it? Wait. Are they flagged? What? Below is a list of the test questions. If you did not answer a question, the word unanswered appears next to the question number. If you marked a question that you wanted to review, the flag will be filled with blue. You can click on a question name to review your answer. You can also use the buttons in the blue bar at the bottom of the screen. Sorry, I guess I'm just used to like timed things. So, what? Answer explanation. So option C is correct. If you chose this option, you notice that the map shows the volcanoes are mostly located along the black lines of the graph, which represent the plate boundary lines. Yeah, so then you can see those mostly on there. Like the only outliers are like here and here and here and here. So that's an even easy way. I was saying, I was saying why they weren't the other ones because it is important. Like there are a lot along the continents. That's why I could see that being, a fake answer because they really want to make sure that you understand that plate boundaries cause volcanoes. So, okay, so the next one. And then energy pyramid, answer explanation. Option D is correct. If you chose option D, you notice that the shape and the structure of the diagram shows that energy is directly transferred from one level to the next, starting from the bottom of the pyramid. Therefore, energy is transferred directly from primary consumers to secondary consumers because they're next to each other on the pyramid. And then it says the other ones of why they weren't. You may have focused on the fact that the producer level does provide energy indirectly to all the other, since it's the bottom. However, the energy period flow directly. Okay, yeah, so these are why they're not correct. So, anyways. And in the sake of time, I mean, we could go through and say it, but I feel like I kind of did say it. So, yeah, there we go. Option C is correct. If you chose option C, you notice that the rates of change in solubility of quinine changes as the temperature increases. The curve in the quinine line, the KNO3 line demonstrates that solubility does not increase at a constant rate as the temperature increases. So yeah, the rate changes. It's still increasing overall, but it would just be a straight line if the rate of change was constant. Like it would just be flatlining, but in that direction. Now here, it's like changing and then it's like flatlining there, whereas this is also changing and then flatline. Or actually no, it's still kind of changing. You can see a curve even from here to there, and then you're ending from here to here. A straight line would be, anyways. It's really drilling it down, but in Kinu, but just be aware that it doesn't matter what these names are. I don't care what kind of salt this is. This could not even be true. I don't know. What I'm saying, or what they're asking, is like whatever these are and whatever this is this correct? And so as long as you know this is increasing in temperature and this is increasing in solubility, and that's how you read a graph. This is the x-axis and the y-axis, and so yeah. All right. So then the next one. All right. So answer explanation. Oh my gosh. Example 1, 2, 3. Oh whoa. Okay. Nice. I like this. So it's like three examples. All right, let's read these. So let's see. Well, first let's read this guide. So in this thread, you're required to cite specific textual evidence and develop a. Sorry, I'll go ahead and read it. The question overview. In this short answer question, you are required to cite specific textual evidence and develop a logical argument. You must select and present evidence from the stimulus and then produce a line of reasoning in order to compose a response for this question. You must also use your understanding of ecosystems and life cycles in order to explain how deforestation can be disruptive. This question tests your skill at the complex task of using, producing, and justifying an argument by incorporating elements from the text into the presentation of your own ideas. All right, so right away, I feel like I should have spent more time writing that thing. And if I did have like an hour, like we're at 42 minutes, so it's a little long for what I wanted for these, but you're not going to be rambling about this and that. You're going to just be looking at this. Although I say that, but a lot of the things, as long as I'm talking about the test and not like, anyways. So let's see, the 3-point response, or let's see, each of the boxes below lists the elements that would need to be present in your response in order to obtain the specified score. After you review these descriptions, click on each of the example tabs above to review actual test taker responses along with explanations of why each response received the score that it did. So already right now I feel like I definitely should have spent some more time on that and like really pick through it. But anyways, so the response contains a clear and well-developed explanation of how deforestation could disrupt the life cycle of blah, blah, in tropical rainforests. Complete support from the passage. Okay, so then 2-point response. An adequate or partially articulated explanation of how deforestation could disrupt the life cycle in tropical rainforests. Partial support from the passage. So right there we did support it with like they needed the ants to survive and the ants needed the trees for the home. But that is pretty basic and like not really complete sentences. So anyways, and then 1 point, minimal or implied explanation of how deforestation could disrupt the life cycle. No, we specifically said the trees. So with deforestation, with less trees, the ants wouldn't have a home, and then the fungus wouldn't have food, and they only feed. And we even pointed out that even though they need plants, which I feel like plants can still grow without trees. That's why I'm hesitant to say anything like that. But yeah, see, responses includes no explanation and no support from the passage. All right, so this is a 3-point, 2-point, and 1-point. Let's look at the 1-point. Without the trees, so spelling, and that cannot grow because they need the trees to disperse spores onto the forest floor in order to grow and reproduce. Now, they do need the trees, but because the ants live in the trees and then the fungus lives in the ants. So let's see. This response gives an explanation on how deforestation could disrupt the life cycle by stating because they need the trees to disperse spores onto the floor in order to grow and reproduce. The response explains how the requires the trees in order to continue its life cycle. However, it does not include any supportive textual evidence from the passage. Okay, so that's a 1-point. And slightly better, the OU feed off of or feed of the carpenter ant which nests in the trees. Deforestation will cause many carpenter ants to die because of the lack of homes. As a result, OU lose many hosts to feed off of, and in turn reproduction is disrupted. Okay, wait. I feel like that's, let's see. This response explains how, this sounds really good to my opinion. I don't know. I want to see example one, but anyways, this response explains how deforestation could disrupt the life cycle of OU by stating deforestation will cause many carpenter ants to die because of the lack of homes. The statement describes how the destruction of the habitat or home of the OU has a negative effect on the life cycle of OU. Wait, that's not really the home of the OU. Wait, the explanation is supported with the following piece of evidence. Feed on the carpenter ant, which nests in the trees. This evidence, which is taken from the last sentence in the paragraph, provides an indirect reference as to how deforestation will destroy the home of the carpenter ant, which will in turn affect the OU. However, this response contains only partial support from the passage. Oh, and therefore it receives a score of 2. Okay, so probably should have probably said they feed. Wait, they feed off of, and in return. All right, let's see example one. Oh, already you can see a lot more effort, a lot more said. So, deforestation destroys the environment where thousands of species of animals flourish, including OU. OU rely heavily on the environment to survive for two major reasons. First of all, see already I feel like this is inflated, like, but anyways, it's saying it. So first of all, OU often find hosts in carpenter ants, which build their nests high up in the trees of rainforests. When deforestation occurs, carpenter ants lose their nests and homes, which would likely result in the diminishment of their species. Okay, so then that's good. They're saying, you know, less trees, less ants. This would disrupt the OU because significantly as or species significantly as OU cannot survive without a host. Okay, so which are the carpenter ants? So that is like a direct link of that. So that's good that they actually included that. There'll be no. Oh yeah. The other reason that OU would suffer is because without the trees, there'd be nothing for them to climb to reach greater amounts of light and less humidity. Okay, so I feel like that was in there. So, anyways, my fault for not taking the time to read it, I guess. While lack of, so we were talking about that though, like the amount of light. So what I was doing if I had like a whole hour to do this, and now we're at 47 minutes. So like even with like I don't know this much back and forth. Let's see. So let's keep going. So the light was what we missed. So we would have gotten probably a 2 point. While lack of trees would lead to more light reaching the ground, the issue of humidity affecting the OU would still exist. With tall trees, and see this, I feel like they're reaching like humidity being affected. It's like how do you affect humidity? Like, is there less humidity, more humidity? These are things that we don't have like proof or evidence of. So you're really inferring that the reader has outside understanding to do that. And again, like plate tectonics was the first thing they asked about. So I don't know. Anyway, so let's see. With tall trees, the OU are able to reach heights with less humidities, but deforestation would leave the OU without a way to escape the humidity, ultimately slowing the growth of the fungus. See right there, slowing the growth. So more light would be bad. I feel like, wait, what? See, now I'm confused. There would be nothing for them to climb to reach greater amounts of light and less humidity, which is bad for fungal growth. I feel like more humidity, less light down in like deep fungal, like that's fungus. While lack of trees would lead to more light reaching the ground, the issue of humidity affecting the OU would still exist. Wait, I feel like that's a double negative thing. Like there is no issue with humidity down in like the darkness of the shade of the trees. It's darker than the sunlight. So, anyways, with tall trees, though you are able to reach heights with less humidity, but deforestation would leave. So, okay, right there, unless the story said, at greater heights there's less humidity, which I could have missed. That's fair. Let's see. Deforestation would have a very significant impact on the life cycle of the OU. For without trees, there'd be no host for the OU to grow, and without a way to escape humidity, there'd be a slowing of growth. So right there, the humidity and the growth, I feel like, is something I just completely missed. So yeah, the 3 point response explains how deforestation could disrupt the life cycle of OU by stating deforestation destroys the environment where thousands of species and animals flourish, including the OU. So no, I would disagree. That is not how it explains how it would. It just says it does, and then this is it. This statement makes the connection between the destruction of the environment and its negative effect on the life cycle of the OU. Like, okay, so that's just answering the question. Maybe it is like it's saying like thousands of species, but it could just say yes, deforestation destroys the environment So yes, it does negatively affect it. Okay, whatever. So this statement makes the connection. And the explanation is supported with the following piece of evidence. Okay, here we go. OU often find hosts in carpenter ants which build their nests high up in the trees of rainforests. Alright, so this piece of evidence links the trees with the living environment of the OU. The explanation is further supported with a second piece of evidence. The other reason that OU would suffer is because without the trees, there would be nothing for them to climb to reach greater amounts of light and less humidity. This piece of evidence links the explanation of a loss of environment back to this statement in the passage which describes how the insects need the light and humidity because those conditions favor growth. Okay, wait. Also, we didn't read the page 2. I don't think we read the page 2 on this one. Let's see. Though this relationship may sound gruesome, researchers note that these parasitic fungi may help maintain biodiversity in the tropical rainforest. Some parasitic fungi may be host-specific, meaning that a fungus species only infects a particular type of insect. Scientists have observed that if an insect population begins to grow, more fungal infections occur, and then the insect population levels off again. This relationship may prevent overpopulation of the habitat by any one insect species. Okay, well, there's nothing about humidity there, but that is some interesting additional insight, which we do know. So with less trees, the ants wouldn't have homes. The OU needs an ant host for the early stages of its life. The OU only seem to feed off of the ant, only using the plant for stable positioning for the pod. So right there, the plant for stable positioning of the pod, I meant by like having the ant bite into the plant, which could be plant or tree. They didn't really say. Like, let's see. It bites into and firmly attaches to a plant. Now, deforestation implies complete vegetation loss, where I kind of feel like just cutting down the trees would be bad, but I feel like there would still be undergrowth unless it was developed into land for like, well, a lot of it is being cleared for cattle, to feed basically like, no, that's not funny, sorry. It's basically to feed America's love for beef, basically. But anyways. So this would be a 2-point answer, I think, but not because, and the humidity. Like, again, let's do a control F. Humidity. Okay, sorry. The insect exhibits such as wandering away from the colony to where light and humidity favor fungal growth. See, right there, it attaches itself to a plant, so it's dying, and the insect bites into a plant. So I don't see humidity anywhere. Do you see humidity here? No. Where is it? Where is it? So I would actually argue this, honestly, because humidity was not described in this fashion, and light, let's look at light. Control F, light. Same thing. This is the only part where light is even talked about. It doesn't say, it just says, the insect exhibits unusual behaviors such as wandering away from the colony to where light and humidity favor fungal growth. So right there, the light and humidity, okay, I guess I can see that, and that's a stretch. And so right here, let's go ahead and say that then. So, um, so they need the ants, and the ants need the trees for the home, but the mold can't live where the home is outside the dead host. So once it's eaten all it needs to and it's ready to repopulate, then it favors, the ant as it's dying carries fungi to better light and humidity conditions. That would be a good, safe way to say it, and that is on me. I did miss that. So, but I looked at that and I saw that. So, again, if I had a little more time, maybe I would think that. So, but again, let's say we got 2 out of 3. In fact, I think there's a way to score this. Well, C, we got that right. So 1 point. Let's see, are these all? So we got C correct. So it's 1, 2. Sorry, I'm also like I actually didn't even look to say. I think it is, but I don't know for sure. I didn't. Okay, yeah, 1 point right there. Multiple choice or 1 point. So 1 point, 1 point, 1 point. Just to be sure, 1 point. Okay. So that's 3 points, and then this is where it gets weird. So this is a 3-point response. So there we go. This is 3 point over here. There's where the little banner is. Okay, so we've got 3 points, which we probably got 2. So we're at 5 out of so much now. Or actually, let's write that down. So 5. This one, C, is correct. It's host specific, or some of the fungi may be host specific parasites. So this wouldn't work on a wide variety of insects. So that we got that. So six out of 7, basically, because we're missing one so far. All right, this one. Yep, that's correct. So a doubling of mass. Wait, and just to make sure, if you chose option C, you notice that in the first 2 rows of the table, a doubling of the mass decreases the acceleration by 2 times when the object's mass is held constant. You may have also noticed that this same pattern also occurs in the last 2 rows of the table. So this one and this one, the 8s and the 16s, a doubling of the mass, so mass is 2 to 4, and then 2 to 4, so that's when it's doubling, so these 2 rows and these 2 rows, decreases or increases the acceleration. So as it doubles, does it increase or decrease? So that's a decrease. And as it increases or as it doubles, this decreases. So yeah, boom, see? And that's where we saw that. So was that 6 out of 7? Or I don't know. We've missed one. So, oh wait, sorry. Chromosomes that are genetic combination, yes, this is C. Okay. I didn't click it. See, and that's why you need to make sure you at least click something and then go back and double check. Always double check your answers before you turn the test in. All right. Okay, and then this one. So D, if you chose D, you notice the statement included experimental evidence which supported the inference that a fish raised in water with a higher level of acidity would have difficulty hearing predatory sounds, which is we proved with all 3 of the other fish didn't hear anything. So we got that. That's still just 1 point. And this one, 1 point, and it's CO2 pressure and position of fish. So we were at CO2, yep, because that's independent, and it changes. So we're changing the pressure in each tank to reflect acidity from increased levels of CO2. So, wait, is that pressure or atmospheric conditions? So I want to say like, microatmospheres of CO2. So that would be, I don't even know what that is. Like, honestly, yeah, the same CO2 pressure right here. Because that implies like, anyways, I guess I just don't understand because like CO2 is like the carbon dioxide gas creates carbonic acid in ocean water. Rising ocean acidity levels may harm marine life, cause hearing loss. So yeah, it's like the pressure popping eardrums or something, or is it just so, I don't know, because pressure you think it like increases as you go deeper in the ocean to where it can even like crush, certain submersible vessels. Ugh. Anyways, whatever. So that is the independent variable, so that's going to change, but it is changing. And like the dependent is the reaction. So the fish not swimming away from the sound was the reaction. So we got the 2 points there. Or no, we only got 1 point. Alright. So we missed 1 point out of the only one that was more than 1. So then this one, oh wait, okay, I spoke too soon because I didn't check it. Alright, so this one, it's because we found what each one of those were divided out because we found this this equation. So we knew that was .31. So we're 0.31. Alright, so, and that is our score. Or wait, we can click next. Either way, we missed 1 point. So let's see, out of 11 points. Or wait, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, still didn't have it. 10, 11, 12. Okay. They're all answered. So now I guess you can review them and then, or what, if we review, oh, I guess it just goes back so you can, anyway, so you can tell yourself what you wanted to look at closer before, but we looked at pretty much all of them close, and that's nigh on 1 hour. Alright, so I did get the science one up finally. I'm going to go ahead and check it out and see if, well, no. Well, it's good. It's good. Ship it. Send it. I'm just kidding. Alright, I'll see you over in math, and then let's actually look at that. Math, social studies, language arts. So I'll probably do social studies and language arts next, and end on math because we already did math and that's a throwback. It's again, if you do it, let's go ahead and so I had that copied to my clipboard. You still want to go
I've got most.
like way far up here, I want to say, or even no, just ignore all that. Go here. That 42 minutes is when I start actually doing the math test. But a lot of that was because I was actually, or no, that's question 5. Let's see. Wait, hold on. Because I was doing this and the code pen at the same time. So apologies for that. I'm not gonna mess with the code pen. Like that is cool when you want to learn HTML and all that stuff. But for now, no, don't even worry about that. So we'll just do these 4 close to hour-ish segments. So, all right. Well, hope you enjoyed that and I hope it's helpful. And I will see you, in I'll see whichever one of these looks better. I'll probably try to do the practice test. I did the science practice test, by the way, last year. I did it like a good few times to make sure I understood why everything was. And so some of that was still from memory. So again, like just do these practice tests, and I'll have these videos, of course, but you can go off on your own and do them. And then like, if they don't make sense, I don't know. Whatever you want to do, that's fine. Just know that you have the ability to do these. I mean, basically, a lot of it's just knowing that, okay, I'll go to GED.com, in a browser, and then I'll go to study, then test previews, and that gets us to free online GED tests. You can see free online sample tests. And then it'll have you do a thing. Well, let's look at it. Language arts. Okay. Here's some information. Okay, I guess it does another thing. Oh, and then you can have answer explanation, which, oh, sorry. I tried not to look at it. I saw kind of where it was. But anyways, I don't want to cheat ourselves on that. So, anyways, I digress. Maybe I'll cut that out. All right. Or not. I'll see you later. See you over in the next one.